Hey, I'm Bruce from 3D Printing Systems, and this is Hayden from Clone
3D Print. We're here today to test out a few props. We've decided to do a test on a 15 horsepower Yamaha, starting out with the original aluminium prop, which was scanned on a ScanMaster.
Plus, yeah.
Yep.
So we 3D scanned that. Yep.
3D scanned it, yep, so that basically sits on a platform and rotates around while the camera takes several photos of it, and then turns it into a digital 3D model.
So then the internal was, we had to CAD up the internals.
The internal spline and everything, a little bit hard for the camera to get right in there and get a good view, so that's simple to CAD up.
Yeah.
And then those two images are meshed together to create the whole prop.
Sounds good. Okay, so what have we got next?
So we've got a range of different materials that we want to try. Starting over here, this is polycarbonate.
Wow.
This still has a bit of support material left on it, which we can break away. We just wanted to show what that looks like in the.
Look at that.
Super easy.
That feels strong.
So the scan just turned out fantastic. Every little detail was pulled out. And it just looks really good.
So polycarbonate.
Polycarbonate. We got a PLA wood mix.
A wooden but propeller.
Yep. Hey, that's the way they used to do it back in the day. So.
No, I think that was an oar, wasn't it?
Oh, that was an oar. Yes, you're right. Same propulsion system.
Okay, I don't think that's going to do so well.
Well, yeah, it might be surprised. It feels really strong. It certainly looks good. Post-processing on this, we did sand it a little bit, and I put an outdoor lacquer, like a deck stain, basically, just to help protect it with the water.
Yep.
Maybe make it last a little bit longer. But that turned out really well.
Okay, next up.
And this one here, our safety prop. This is ABS, printed in bright yellow, just to keep them all looking different. But that one.
So if you're a scuba diver, that's the one you watch out for.
That's the one you watch out for. Yep, perfect for you, buck. And the last one here is a
carbon fibre.
Carbon fibre, that's right.
Carbon fibre. Oh, that's going to do the best.
Yeah.
I'll bet you a case of beers that's going to...
A case of beers. Hey, you're on.
Oh, yeah?
I think we're either the wood or the polycarbonate. So
yeah, I think they'll be laughing at you if the wooden one fails and shatters into 1,000 bits.
Yeah, well, hey, it'll be dramatic and we'll catch it on camera. So.
Yep. Okay, we'll get back at you, we'll set up the rig and we'll test out these props.
Yeah, sounds good. Okay, so we're going to start out with the carbon fibre PLA propeller. First one. We'll slide this on. The washer in behind there. We'll put her in here. Just organise our highly sophisticated underwater camera.
Hopeful that
You want to get those beers now, Bruce, or you want to wait until we test the props that'll actually work? That's not bad though. That's not bad at all. I mean, hey, if you were stuck at sea and you needed a prop to get you home, it'll get you home. Safety diver's propeller. So on here, we'll see how this one goes. That looks as good as what we put it on.
So this can make it to the next phase of our test.
Oh, absolutely. This will go on the boat. Yeah.
That is a really good fit.
Yeah. Hey, it all comes down to good scanning and good CAD abilities. Just working out the right tolerances and I mean, hey, that wash has been coming off with the propeller every time, and it just slots out like it's a perfect fit.
Snap lock, yeah, yeah. And this is like being, you know, that center core was CADed up.
Yeah.
But the rest of the prop, you know, it's spot on for the scanner to achieve that.
Yeah, yeah.
Okay, let's get
prop?
on to the next prop. What's the next one?
Either the polycarbonate or the wood. Which one you want to go for?
Let's go for the wood, mate.
Wood, right.
So I want to go on properly, Hayden.
So I've liberally coated this with an exterior lacquer.
Oh, you're cheating.
Hey, just trying to keep the water out.
Let's get some wood on wood action.
Here she goes. So that one's going to go into the water, the next phase. Absolutely no issues with it, no delamination.
That's better than the carbon fibre.
Better than the carbon fibre, who would have thought?
Oh my gosh.
Hey, if you want an engineering plastic, wood is what you're after.
What is it? So Hayden, what's up next?
So the last one we've got in the lineup is the polycarbonate. This one's still got a bit of support material on there. This came out of the printer for those of you that want to see how easy it is to remove the support. You know, that's a solid piece of support. These are all the structures inside. Just as simple as that.
That's quite amazing, eh?
Yeah.
And this is what bulletproof glass is made of.
Absolutely.
So if we shoot through the water into the prop for James Bond movie, we should be good.
We should be good. Absolutely.
Right, let's give it a go.
Yeah, so I'll be most embarrassed if this doesn't work as well as the wooden propeller, being a real engineering plastic. And obviously the tank empties out pretty quick, but hey, that was nearly full throttle, and I really think that'll work as a replacement prop.
So we're all set for the test.
Okay, time for the ABS prop. Yeah, so as you can see when I was going out there, trying to get up on the plane, giving it a bit more horsepower, and just felt the prop lose grip. So we'll see what's happened. That's it. So that's in gear. We can see that the shaft isn't moving. The propeller is.
So is it cracked? Oh yeah.
It has cracked, and it has spun the bush inside. Next up, the PLA wood. I think this is going to do well.
Okay, so we just got back, cleaned off the boat, washed it off. And what was the problem? Why didn't it spin so well?
So we got a spline in the centre, and this is something that you would work on with a prototype or something like that. I mean, you test it and you find out how it would fail, and you can make improvements on it. The spline in here actually only goes halfway down the prop. Now this is fine for an aluminium prop, but for, you know, we're pushing to the limits with this.
A wooden prop.
With a wooden prop. So those splines only go to about here, and they only had contact of about maybe 20 mils. So so that contact wasn't enough, and it's
spun it completely off. Yeah.
And we can see when we look inside that the splines have been cleaned completely off. Now, you know, hey, you make a couple of small improvements with that. For a wooden propeller, it shows no sign of stress apart from those splines.
So the fins are all good?
They all look good. Everything looks great.
So just to summarise now, so a wooden one kind of could have passed?
Yeah, I think so, with just a minor improvement. And wood's good.
And the ABS one?
The ABS was not quite as good. It wasn't as good as what I thought it would be, but
because I think we had a crack line on...
We had a crack line in the ABS one, plus it spun the shaft as well. So that didn't perform as well as this one.
Yeah, carbon fibre completely out of it.
Completely out, yeah. That didn't even make it past the tank.
So polycarbonate number one.
Number one, yep, we got a good run with that. I didn't have to paddle home.
Are you a case of beers in that one?
And number two would be the PLA wood.
PLA wood. Number three is ABS.
ABS.
And four is carbon fibre.
Carbon fibre.
Now we were going to try a nylon one.
Yeah.
But getting support material off the nylon one proved to be more of a challenge than it's worth. So we left the nylon one out of it. Maybe next time. Yeah.
Hey, a nylon I'm sure would have worked great, but it, like you say, it's very difficult to remove the support material, and because of the shape of the prop, we needed to use a lot of support material.
No, well, I'm off to design up a chainsaw.
Excellent.
And I'm going to print it in wood and cut down a forest.
That sounds great.
Till next time.
Till next time.